In this video, we're going to go over the review for our CUA 5. So number 1 says, given g of x is a transformation of f of x equals e to the x, write an equation of g of x if f of x is reflected over the x-axis, translated 5 units to the right, 4 units up, and vertically stretched by a factor of 3. So we start taking it piece by piece. So first thing is to make it reflected over the x-axis. That means that we are going to put a negative in front of the function. So we have g of x equals, and we're going to have a negative sign in front of our e to the x power. Then to show that it has been translated 5 units to the right, remember it's going to look opposite of what it is, and it's going to be up with the x, so it's going to be a minus 5. To show that it has been moved up 4 units, we're going to have plus 4 at the very end. Notice it's not as the exponent. And then the last piece is vertically stretched by a factor of 3, which means we're going to put a 3 out in front. So if you were to graph this in the original function, you would be able to see that these transformations took place. So just to show you, you would be graphing on our handheld calculators. Oops, let me pull up the graph. So if I graphed e to the x, and then I graphed our transformed function, which was negative 3 e to the x minus 5 plus 4. So make sure that 4 would not be in the exponent, so plus 4 like that. And look, it has been shifted 4 units up, 5 units to the right, and has a reflection about the x-axis and a vertical stretch of 3. So you can always graph to make sure it moves how it's supposed to. So that would be our final answer. Number 2, use common bases to solve the given equation. So what we need to do is we need to rewrite these to have common bases. So typically you want to start with the bigger number and figure out if you can rewrite it with a base of 3. So in this case, 81 is 3 to the 4th power. So we're going to rewrite them. This left side stays the same. This right side is going to change to be 3 to the 4th power. Now remember, when we have a power to a power, we end up multiplying. So that would be 4 times 11, or x minus 11. So now that we've done that, our bases are the same. So therefore, we can set our exponents equal to each other. While I do this, I'm going to go ahead and distribute that 4 and get 4x. And then distribute that 4 to the negative 11 and get negative 44. So now I am going to move my x's. I'm going to move the 1x. Let me go ahead and do that in a different color. So I'm going to subtract x from both sides. And at the same time, I'm going to add 44 to both sides. So I'm doing 2 steps in one. So the x's cancel out. 4 plus 44 is 48. 4x minus x is 3x. So I'm going to take 48 and divide it by 3. And x is equal to 16. So if I wanted to confirm that my answer was correct, I could plug it back in. So if I'm checking my answer, I would do 3 to the 16 plus 4 power. And so when I type that into the calculator, I get a really big number, 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. And so then I type it into the other side, 81 to the 16 minus 11 power. So type that in. And I get the exact same number, 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. So this checks out. Our answer did work. Okay. When I look at number 3, it says given g of x is a transformation of a parent function, identify the parent function and how it's being transformed. So remember, anytime we're looking for the parent function, we would end up taking off anything that would cause a transformation. So this 1/3 would cause a transformation. This negative 3x would cause a transformation. And this 5 would cause a transformation. So what does that leave us with? Well, that just leaves us with 2 to the x power. So parent function would be f of x equals 2 to the x power. So there we go for that. So then if I remove all that, we can talk about the transformations. So this right here is a 1/3, which is causing a vertical compression. This negative sign is causing it to reflect over the y-axis. The 3 is causing a horizontal compression. Of 1/3, and the 5 is causing it to be moved down 5 units. So that would be all the transformations there. Okay, moving on to the next question. It says write each log equation in exponential form. So we're going to go ahead and rewrite these in exponential form. So you do need to know how to convert it. So if we have log with a base equal to a number, or of a number equal to a power, then it's going to be the base to the power equals the number. So what we're going to do is we are going to identify all this. So in letter A, the log x of 4, notice my log does not clearly have a base written. So we need to remember that that is a base 10. So I have 10 to the 4th power equals x. And that would be it for the transformation. The switching it back and forth. Next one is the natural log of 5 equals x. The natural log is e, has a base of e. And then the power is going to be x, and it's going to equal 5. Looking at my next one, I have log base 2 of 32 equals 5. So I have, 2 to the 5th power equals 32. Looking back at this one, it is not a horizontal compression. I'm sorry, it should have been a horizontal stretch of 1/3. Those horizontal ones can be tricky, but it should be a stretch. Okay. Looking at the next one, it says, which of the following represents f of x equals 1/2 to the x power and its inverse g of x equaling log of 1/2 of x on the same coordinate plane? So we're going to graph these on the same calculator. So you graph them on yours, I'll graph them on mine. If you're using the 84s, remember to get logs of different bases. You hit alpha window 5. Alpha window 5. So we're going to go ahead and graph them. So our first one is 1/2 to the x power. That's going to be graphed in blue. Oh, let me erase the ones that I have. Oops. So there's, oh, it's actually not graphed in blue, it's graphed in black. So then we'll add the next one, which is log base 1/2 of x. That one's graphed in red. So we should be looking for a function that looks like this. So if we look at them, the one that looks closest to it would be D. Okay, so next one. Donna is saving up for college, so she invests $200 in a savings account that earns 4.8 interest that is compounded continuously. How much money would be in Donna's account after 4 years? So did you see the key phrase? Compounded continuously. So that means that we're going to use the formula A equals P times E to the RT power. So we were given P. P was how much she started, which was $200. Our rate was 4.8%, so we move that decimal 2 places to the left, so we get 0.048. And then the time we were given was 4 years after high school. So after 4 years of high school, that would be 4. So we're going to plug this information in and then type it into our calculator. So we have 200, remember E is a button on our calculator, to the power of 0.048 times 4. Since it's money, we are going to round to 2 decimal places. So we have 200 second ln gets you E. And so after 4 years in the account, there would be $242.33. Looking at the next one. Jacob is saving up to buy a car. He invests $1,250 in a savings account that earns 3.2% interest compounded quarterly. How much is in the account after 2 years? So, key phrase, compounded quarterly, which tells us that we're using A equals P times 1 plus R divided by N to the NT power. So, he invests $1,250. That's going to be our P times 1 plus our interest rate. Our interest rate is 3.2%. Move that 2 places to the left. So it's going to be 0.032. 2. Then it said compounded quarterly, which means n is 4, so that's going to go in 2 different spots. And then last but not least, we want to know after how many years. So it's going to be 2 years. And then we're going to type that into the calculator exactly as it looks. And so after 2 years, there would be $1,332.28. Moving on to the next one, use the graph to answer the following questions about f of x, which is log base 2 of x plus 3 minus 2. So let's go ahead and graph that on our calculator. So alpha window 5, our base is 2. We have x plus 3 and then minus 2. So we hit graph. If we're talking about the domain, we see that it has been moved to the left 3. So our domain starts where this asymptote is. Okay, so right here, it's going to start here, and it's going to go on forever towards infinity. Well, that asymptote is at -3. So our domain is -3 to infinity. Our range for all log functions is -infinity to +infinity. The y-intercept here, if you can't tell on the graph, which we should be able to, it's right here at 1. You could hit second trace value, type in 0, and it does give you, oh, sorry, that was the x-intercept that I was looking at, the y-intercept. So this one's not as pretty to see, so that's this one. That's my bad. So the y-intercept, if you hit second trace, then number 1, that says value, and for x, we're going to type in 0. We do get a messy little decimal, which is about -0.415 to 3 decimal places. So again, second trace 1, and then type in 0 and press enter. The x-intercept, that was the one that I was looking at earlier. The x-intercept, if we're looking at that, that is at 1. So that's this one right here. So that is clearly crossing at 1. So 1, 0. Okay, what is the equation of the asymptote? So since it is a vertical asymptote, it gets an x equals, and it's going through -3. So x equals -3. So you do need to make sure that you're able to type this in the calculator and at least able to find the x and y intercepts using the calculator. If you hit second graph and look at the table, you will see at -3, it starts saying error, and that's how we can get the asymptote. Okay, number 9, use properties to expand the expression. So notice I have 3 different variables. I have x, I have y, I have z. So my final answer should have 3 different natural logs. So remember, when it's in the numerator on top, it gets a plus sign. When it's in the denominator, it gets a minus sign. So we have the natural log of the square root of x plus, because y is on top, the natural log of y to the 3rd power. And then minus, because z is on bottom, the natural log of z to the 4th. Now, that square root of x, remember when we have the square root of x, it can be rewritten as x to the 1/2 power. So this turns into the natural log of x to the 1/2 power. Everything else I'm going to keep the same for now. Then we're going to take all of these exponents and drop them in front of their respective log to get our final answer. So we have 1/2 the natural log of x plus 3 the natural log of y minus 4 the natural log of z. And that is our final answer. Looking at number 10, use the properties of log to compress the given expression. So now we're going the opposite way. So we're going to start with all of these numbers that are out in front, and they're going to become the exponents of their respected variables. So log base 2 of x to the 4th plus log base 2 of y to the 1/2 minus 3, oh, nope, the 3 is moving, minus log base 2 of z to the 3rd power. Okay, same concept as before. This is going to turn into the square root. So I'm going to do that in the next step. But I'm also going to condense it at the same time. This has a plus sign, so those two will be going in the numerator. This has a minus sign, so it will be going in the denominator. So everything gets 1 log. On top, we're going to have x to the 4th times that y is going to turn into the square root of y, and it's all going to be over z to the 3rd power, and that would be our final answer right there. Looking at number 11, solve the log equation. So there's no way to get common bases because I only have one single log. So we're going to switch to exponential form. So currently we have it in the form of log of a number equals a power. So because there's no base written, that means that it's a base 10 to a power equals a number. So we have 10 to the 2nd power equals 3x plus 10. Well, 10 to the 2nd power is 100. We get 3x plus 10. If I subtract 10 from both sides, uh, 100 minus 10 is 90 equals 3x. When we divide by 3 on both sides, we get x equals 30. And that will be the answer that we think. So we do have to make sure that we check our answer and we plug it back in to make sure it all works out. So log of 3 times 30 plus 10. We do need to make sure that when we type that into the calculator, we get 2. So this log button is next to the number 7. So we type in 3 times 30 plus 10, and it does check out. We do get 2. So I'm going to give us a check mark because we checked our answer and we are sure that it's right. Okay, this next one, we need to solve this equation. We cannot rewrite this with common bases. So we have a base to a power equals a number. So we're going to switch it to log form. So log of a base of a number equals the power. So this turns into log base 5 of 21 equals 4 minus 2x. Before I type that in, I'm going to go ahead and subtract 4 from it. Oh my goodness. Now, the 4 cannot be subtracted from the number in the log. So it's just going to be log base 5 of 21, close the parentheses, minus 4 equals a negative 2x because these cancel out. Then I'm going to divide both sides by negative 2. And everything has to be divided by negative 2. And I'm going to type it all in at one time so I don't have to keep typing in things. Okay, so I'm going to start with the fraction button, alpha x, and then alpha window 5 log base 2 of 21 outside the parentheses minus 4, and it's all divided by a negative 2, and that gives me the x value of, to 3 decimal places, negative 0.196. Okay, so you can type that back in to the original expression just to make sure. So if I type in 5 to the power of 4 minus 2 times the answer that I got in my calculator, it should work out. Okay, so moving on to the next one. This is a spiraled in question. So for this, remember, two things we need are the zeros, and then we need to see when it's going to be below or above the x-axis. So I set this equal to 0, and I set this equal to 0. And I solve for x, so I get x equals 4. I get x equals negative 6. Because there's no line underneath my inequality sign, there will be open circles. So negative 6 is not on here, so I'm going to add it. So negative 6 is going to be right here. So open circle at negative 6, open circle at 4. I'm going to graph this on my calculator. So I have x minus 4 squared times x plus 6. I graph it. I'm going to sketch a rough sketch of it. So negative 6 is here, 4 is here, so it looks like it's going like this. And then it's bouncing and going back up. Okay, so these are, again, 6 and 4. We want when it is below the x-axis. So when is it below the x-axis? That is this piece right here. So when I graph this, it is going to be just this arrow shaded. But we do need to make sure that we have both of those circles there. Okay, if it were the area between negative 6 and 4 and so on, we would shade in the middle and the other piece. Okay, looking at number 4. Oh, now that I'm looking at number 12, I think I typed it into the calculator wrong. So let me retype that in. Alpha window 5. I think I typed in a base 2 instead of base 5. So let me retype it, make sure I got the right number. There we go. So I did not get the right number. I know you're probably freaking out in that video or while you're watching this. So it should be 1.054. So hopefully that's what you got when you did that. Okay, so when you plug it back in, it should work now, because what I wrote originally did not work. Okay, so make sure you fix that on number 12. Number 14, we have the natural log of 2 plus the natural log of 8x plus 10 equals the natural log of 11x plus 5. So we see that we have multiple logs. We do need to condense them on that left side. When I have two logs being added, I can condense them by multiplying. So it would be 2 times 8x minus 10. The right side gets to stay the same. And now that my bases are the same and I have one natural log on each side, I can go ahead and drop them and set what's inside equal to each other. So I'm going to go ahead and multiply 2 times 8x, that is 16x. 2 times negative 10 is a negative 20, equals 11x plus 5. I'm going to go ahead and move over the 20 by adding 20 to both sides. And I'm going to subtract 11x from both sides. And so when we do that, we get 5x equals 25. And then I divide both sides by 5. And I get x equals 5. So, just to make sure that I don't make the same mistake like I did on the one above, let's type it in and make sure we get the same thing to check our answers. So the natural log of 2 plus the natural log of 8 times 5 minus 10. I get about 4.09. If I type in the other side, the natural log of 11 times 5 plus 5, I get the same decimal, so it does check out. So please make sure you check your work. And then this last question is for my honors classes only. So if you're not in an honors class, then you can skip this question. So the half-life of zinc 71 is 124.3 years. How much of a 120 gram sample is present after 210 years? So what we need to do is remember our formula. So our formula for this was y equals a times b to the t divided by n power. So our initial amount was that 120 grams. So we have y equals 120. B is the growth or decay rate. That was the half-life part, so that is 1/2. And T is how long after how many years are we trying to find? And we want to find after 210 years. And we have to divide that by how long the half-life takes. And the half-life takes 124.3 years. And then we just type that into our handy dandy calculator. So 120 times 1/2 to the 210 divided by 124.3. So after 210 years, there will be about 37.205 grams left. Okay, so hopefully this helps. If you had any questions on the review, if you have any questions after you watch this video, please make sure you ask before the test. And good luck on the test.